Kirkle Math. Here we go, ladies and gentlemen. We are on to 8.3. We have left vertex form behind for a little bit, and we're going to dive into standard form of quadratic equations. You are in your student companion on page 176 to 177. Here we go. So this right here is standard form of the quadratic equation. So it looks just like the standard form of other types of equations that we have worked on, like linear equations and exponential equations, where we have a times x squared plus b times x plus c. But this time we're focusing on it representing just quadratic equations. Okay, so we're going to take a look at what each of these pieces mean and kind of unravel it and figure out how to graph with it and really understand standard form. So the first thing we're going to do here is understand what c represents in our function. Okay, what is c in our equation? Here we have an example where we can visually see what happens when I move my slider to change c. So right now c is 0. So you can see that's why it's negative 2x squared plus 4x plus nothing, because c is 0. If I make c larger, my parabola moves up. If I make c smaller than 0, my parabola moves down. But if you notice, it's not, look at where my point is on this diagram here we're showing. It's not where the vertex is. It's not the vertex that's moving. It's our y-intercept. So when c is 0, then my y-intercept is 0. When c is 1, my y-intercept is 1. And same when I move it down. So over here, c is our y value, our y-intercept of the graph. So when we go and practice this, you're going to take a look at this equation right here. Or I'm sorry, this is just the standard form of quadratics, like the parent or the basic function here. We're going to evaluate this if x is 0. So if I go and replace x with 0, okay, so let me actually go over here and show you. If I go over here and instead of a times x squared, I do a times 0. And instead of b times x, I do b times 0. Okay, how does that relate to what we did in example 1, to what we did on this page here? Okay, how does that relate? Give that a try. All right, now here you can see this is the standard form of a quadratic function. It gives you the equation again, and it lets you know that where a is not equal to 0, so a has to be 1 or greater, or has to be greater than 0 or less than 0. Then it explains that the value of c is the y-intercept of the graph, which we just talked about. And then it gives us some new information, and I wrote it bigger over here on the right. The axis of symmetry is a line that goes through x equals b, or negative b divided by 2a. Okay, so that is our line of symmetry. So if I go back into my equation here and I take b, whatever the coefficient of x is, and I divide it by 2 times whatever the coefficient of x squared is, and I make it negative, that is where my line, my axis of symmetry is, okay? That is also, I know it's kind of hard to see down here, but if I move it up a little bit, but that is also the same way that I find the x coordinate of my vertex. So when you go to graph this quadratic function, as you're going to see soon, I'm going to do this negative b over 2a. I'm going to use that to find the line of symmetry and to find the x coordinate of the vertex. Okay, so now we're going to take the information that we've learned and we're going to graph this quadratic function in standard form and find the axis of symmetry, the vertex, and the y-intercept. Now going back to what we learned before, c is the y-intercept. So if I look at my problem down here, I automatically know that the y-intercept is 3 because c is 3. So when I go to graph, I could put a point at 3. I know that it's going to go through this point in some way. I don't know if this is the vertex. I don't know if this is the right side or the left side, but it is going to intersect the y-axis at 3. Okay? Then I need to find, really the first step though that you need to worry about is finding the axis of symmetry. That's the first thing you do, because if you can find your axis of symmetry, then we can start plotting our vertex and plotting our points on the right and left. Okay, the way we're going to do that is right here, right? The axis of symmetry is negative b over 2a. And you can see here, I would be taking notes on this, negative b over 2a in this problem. Remember, down here, let me change colors on you. B is 4, this is C, and A is 2. So negative 4 divided by 2 times 2 is negative 1. So therefore the axis of symmetry is negative 1, and my vertex is going to fall somewhere on this line. The x coordinate of my vertex is negative 1. The second step I'm going to do is use this x coordinate to find the y coordinate of my vertex, because I need to plot my vertex, right? So I am going to take my formula. I know that x is, let me clear this out down here. I know that x is negative 1. So let's just replace x with negative 1 in my formula. Okay. Oh my gosh. Go away. There we go. I know that x is, sorry. I know that x is negative 1. So I'm going to do 2 times negative 1 squared plus 4 times negative 1 plus 3, and that is going to give me my f of x, or in other words, my y value. Okay, so once they solved this, they got 1. So the y coordinate of the vertex is 1, and that's why they plotted their vertex at negative 1, 1. Negative 1 coming from their axis of symmetry, and the 1 coming from substituting that axis of symmetry into the equation and solving for y. Okay. Step 3, now that I know where my vertex is and I know where my axis of symmetry is, I'm now going to plot the y-intercept and its reflection. Okay, we know that C is my y-intercept, so that's going to go at 3, 0, 3. And then I'm going to reflect it across the axis of symmetry to give me my other point, negative 2, 3. And then finally, I'm going to plot another point and its reflection. So this is just like the other one where I'm now going to pick one place to the right of my vertex. So that would be 0, or I actually already have 0, sorry. One place to the right of where my y-intercept is. You're moving over. I'm going to pick the number 1, and I'm going to figure out what the point is if x is 1. So I'm going to do the same thing where I'm going to plug 1 in to my equation, positive 1 this time. So I'll show you, I'm going to do 2 times positive 1 squared plus 4 times positive 1 plus 3, and that's going to give me my y value for this second point. And they found it out to be 1 and 9. So they plotted that point, and then they reflected it across the axis and got negative 3, 9 as well. Then finally, you just graph your parabola. You're just going to draw a smooth line through those points, and now your standard form quadratic function is graphed. Okay, let's do that again, but on one of your try-its that you have in your book, okay? I have my steps over here, I have my formula, and we're going to work through it on our own. So the first thing it says to do is to find the axis of symmetry. And to find the axis of symmetry, I'm using this formula right here, negative b over 2a. So I'm going to go ahead over here. A is 1, because there's an invisible 1 there. B is 2, and C is 4. So x is going to be equal to negative 2 over 2 times 1. Okay? Negative 2 over 2 is the same as negative 1. So x, in this case, is also equal to negative 1. Okay? I'm going to type it over here so that we remember. We got negative 1. That is my my axis of symmetry, and it's the x value of my vertex. Okay. To make space, I'm going to erase this, so I can do the next step. So now that I found my axis of symmetry, x is 1, my x value of the vertex, I'm going to find the y value of the vertex. So I'm going to take this equation and I'm going to replace x with -1. So f of -1 is equal to -1 squared plus 2 times -1 plus 4. That's going to be 1 plus -2 plus 4. Let's see, 4 take away 2 is 2 plus 1 is 3. So my y value, or my f of x, is 3. So my coordinates, if I take the x over here, -1, and my y, my my vertex is going to be -1, 3. And again, I'm just typing them over here so that we can keep them out of the way, because I'm probably going to keep erasing these things. So feel free to pause the video and take notes as we go. So that was step 2. So I've now done step 1 and step 2. Okay. Now I'm going to do step 3, and I'm going to plot the y-intercept and its reflection. So remember, the y-intercept is just c. So I know my y-intercept is +4. So again, my y-intercept is equal to 4. Okay, so now I'm going to start plotting. So I know that my vertex is at -1, sorry, this way, -1, 3, 1, take this one, -1, 1, 2, 3-ish. I know that my y-intercept is +4, so I'm going to go ahead and put a dot at 0, 4. And then I'm going to reflect it over my line of symmetry here, and that's going to put my other dot here. Okay, we can double check now that that is correct by checking step 4. So we have done this, and plotting another point in its reflection. So I'm going to just plug in, okay, I'm going to figure out what if x is 1. I want to know if it's going to equal 7. So f of x is, what if f of 1 is equal to 1 squared plus 2 times 1 plus 4. 1 squared is 1 plus 2 plus 4, and that is 4, 5, 6, 7. So my y value here would be 7, and that's what I have here. So then I would graph my parabola, which is already done. Check, check. I am done. We're going to check our answer here. -1, 3, 0, 4, 1, 7. Check my answer here. We got it. Go ahead and try the next one on your own. Hi. All right, this is the last example we're going to go over. Example 3, we have 2 fountains here. The trajectory of the water from fountain A is represented by this function, and the trajectory of fountain B is represented by this table of points. We are going to compare pieces of these quadratic functions in order to compare the fountains. So they want us to compare the vertex of each function, the highest point in this case, which and we want to know which trajectory reaches a higher height in feet. Okay, which of these fountains goes up the highest? So I'm going to find the vertex in fountain A by using my little formula here, -b over 2a. B is 2, A is -1, and they get x is 1. Then we just plug in 1 for x into my function and solve, and they get y is 9. So the vertex of fountain A is 1, 9, which means it reaches a height of 9 feet. For fountain B, we're looking for this peak of my parabola. We're looking for the turnaround. So you should see that my numbers are going up, up, up in y, and then they start going down, down, down. So wherever they get the highest is my peak. So the vertex is -4, 10, which means fountain B reaches a height of 10 feet. Now your job is to do the same thing, but you're going to do it with this equation here. So here I kind of laid out what you need to do. Find the vertex using this formula of this equation. Then find the y-coordinate by plugging in what you got for part A here into part B. And then compare your answer with the vertex, or the highest point, of your graph. Good luck.